Hello, what's up, guys? Welcome back. The day, some more problems. Yeah, I plan to, I don't know, work on maybe the fraternity application. Do some leak code, work on the fraternity application. I don't really know. Just trying to figure it out. But we'll start with some leak code. So. Fraternity application. Yo, Dahel, what's up, bro? Thanks for stopping by, dude. Let's take a look at the daily problem. Power grid maintenance. Even integer C representing C power stations, each with unique identifier ID 1 to C, 1 index base. These stations are connected via bidirectional cables. Each element connections I is UI VI indicates connection between station UI and station VI, stations that are directly or indirectly connected from a form of power grid. Initially, all stations are online operational. You're also given a 2D array queries, where each query is one of the following two types. 1X, a maintenance check. It's a question for station X. If station X is online, it resolves the check by itself. Maintenance check, okay. Station X is offline. The check is resolved by the operational station's smallest ID. Okay. I'm about to sleep through literally laying on the bed. Oh shit. That's okay. What's up, Devon? What's up, guys? Appreciate you guys joining in. Starting off with a little bit of leak code, bro. I'm trying to figure out exactly what we have to do. So we're given C, right? C being representing C power stations, right? So this is the amount of power stations. We have a connections here that this connects to this power station, right? Initially all stations are online operational. Connections UI VI indicates a connection between UI and station VI. Stations that are directly or indirectly connected form a power grid. Okay. Initially all stations are online. These are our queries. Queries. Looks like if there's a 1 to something else, this means it's a maintenance check. 2 to something else means the station goes offline, i.e. becomes non-operational. So 1X, a maintenance check is requested for station X. If station X is online, it resolves the check by itself. If station X is offline, the check is resolved by the operational station with the smallest ID in the same power grid as X. This is what kind of confuses me here. This little statement here, I'm a little bit confused what this means. If no operational station exists in that grid, return -1. Okay, so they start off with query 1.3, right? Station 3 is online because everything is online initially. So the maintenance check is resolved by station 3. Okay. Online in form of single power grid. Okay. Do you know the size of an empty class in C++? I think I don't know, doesn't the size of an empty class, doesn't it depend on everything that's inside of the class? So maybe initially, maybe it would be just 1 byte. I don't know. Is that right? Just for like, I mean, an empty class needs somewhere in memory to be stored. So I don't know if exactly is 1 byte, but you know, I would say a class, yeah, class just the memory represents what's actually in it. It's all the integers, all the floats, you know, what was actually in the class. I hope that's right. I don't know. How many bytes is an empty class in C++? Oh, there you go. I was right. 1 byte. There we go. Type shit, bro. So an empty class is 1 byte. That every object, even though it's an empty class, has a unique memory address. Yeah. There we go. Damn, bro. Is this like coding Jesus, bro? type shit, dude. Station 2. So station 1 goes offline because we get a 2-1. Station X goes offline. Okay. Right. So then query 1-1. Station 1 is offline, so the check is resolved by the operational station with the smallest ID among 2345, which is station 2. You are fucking right. Let's go, dude. Let's go. Give me some more questions, bro. Quiz me, bro. This is like coding Jesus, dude. I don't know. I'm not that amazing, but maybe I know. Code Jesus type of question. Yeah, bro. Type shit, bro. So here we go. So the station 2 goes offline. The remaining online stations are 3, 4, 5. Station 2 is offline, so the check is resolved by the operational station with the smallest ID among 3, 4, 5, which is station 3. Bro, I don't want to demotivate you, but this problem is really fucked me up today. Yeah, it seems like a hard problem. You know, you were cooked when you see 5 hits. So, I mean, I don't know the perfect way to solve this. 0, 1, 2, so these are the connections, right? So obviously we know that this is some sort of graph problem, so maybe I can make some sort of an adjacency list that so we can have the connections here properly, and then we can query it based on the connections. Maybe that's a good start. I don't know. Take a look here. The graph problem. Yeah, I'm gonna go with that. So we have a vector of a vector of connections. Let's create like some sort of, I don't know, like unordered map of, if you are good with graphs, you can solve it. Yeah, I mean, I'm okay, I think, but unordered map, intent, the return type, let's call this get adjacency list. And let's pass in a vector of a vector of, yeah, you're in the right path. Okay. All right. Well, let's try that first. Let's create an adjacency list here. Let's see. Let's actually look at the constraints here. So we could have 10 to the power of 5 thingos, 1. Okay. Did you know that size of is not a function? Did I know that size of is not a function? To be honest, not really. Is an operator. Okay. Yeah, cool. I mean, yeah, I don't know. I probably wouldn't have like, I mean, not really off the top of my head, but I can see why it's probably an operator. I don't know. I'm no C++ god, bro. So I'm trying to get better, but it is my favorite language, but I'm trying to get better. Like, okay. So how exactly do we want to do this, right? We probably want to define some sort of unordered map here. So let's create an unordered map here of integers, and we can call it like our adjacency list, right? So let's loop through, right? So for, how do we want to do this, right? I don't want my first key to be 0, right? I want to store this as, let's think about this, right? So we would go, where are you from, bro? Are you talking about me? I'm from Australia, bro. I'm from Australia, but I live in the US. 1, 2, 2, 3, 3, 4, 4, 5. Obviously, this being the node and this being the destination here, so Okay. Let's just loop through it, right? So let's go like for C in connections, right? I don't think we need the index value here, right? We just need to get, so let's do like for, so maybe we need the index value here. So let's do like to I0, I is less than size I plus plus, right? Let's do for C in connections I, right? I can't remember if this is the syntax or not. I think it is, but side of here, we can grab, we can do, shit, how do we access this? That's the thing. I don't know off the top of my head. How can we access, 2000 nested vector? Okay, so const auto C in connections I. Int first val is equal to C1, sorry, C0. Int second val is equal to C1. Okay, so we got these two values. Right now, what do we want to do with them? Well, we want the first value to be the key, right? And the second value to be the destination here, right? But I feel like we could have multiple destinations here, right? This could be an array of multiple different destinations, right? Or is it? Queries I can be of length 2. Is either 1 or 2, right? So can this be, the question is can this graph be multiple different directions? Like what I'm saying is like, can one be pointing to, is it a straight, you know, line of nodes the whole way? That's what I'm confused about. I should probably clarify that. Multiple neighbors as an undirected connected graph where each node a power station or city a transmission line. No, the grid can always, no, it doesn't have to be a straight line or a path. Forming trees or general graph cycles me. Okay, so I think we're gonna have to build so this here is going to have to be a vector of integers, right? We have our first value and our second value here. What do we want to do with that? Well, we want to go adjacency list A. Adjacency list. Let's call this int A and int B. I think it makes it easier. Less typing. Adjacency list A. Dot append B, right? And then we need to do adjacency list B dot append A, right? Let's append both because could be, actually append both because undirected graph, right? So this is an undirected graph here. We obviously want to change this, our return type here being a vector of integers. That looks good. I think we need just one. Yeah. Okay. And then we literally just want to return our adjacency list, right? I believe this should work. Right? This should create an adjacency list here that maps everything, right? We just need to call it. Let's do get adjacency list, right? And we pass in our connections, right? And we obviously want to create our adjacency list. We can go adjacency list, unordered map int vector of integers get adjacency equals get adjacency list. I believe that should work. I believe this function is correct for the adjacency list we want to create. I just want to make sure. I believe this should be a correct adjacency list here. Okay, so vectors use pushback. So that's what I missed here. This uses pushback. Can never remember what the methods are, to be honest. Pushback. I guess actually, yeah, no, we wouldn't need this actually. Whoops. This will just be like a const auto reference C in connections, right? Because we would instantly know we only have two, right? Queries I, connections I dot length is always 2, so therefore we don't even need a nested loop, right? We instantly know that it's 2, so we can just return 0 and 1. Console reference C in connections. We can append that. Yep, looks good. And we can push back. Let's return what our, let's create some sort of print function for unordered map integer. I like to visualize everything that I'm looking at. I think it's easier to move through the problem. So that's what I like to do here. I'm just gonna generate a print function here. So I don't want to write it myself. So that's a nice print function here, right? Prints the node and the neighbors. Yo, what's up? GG, bro. GG. GGG. What's up, dude? Thanks for stopping by on the stream, bro. Let's pass in our... Oh, we didn't give it a name. Whoops. Adjacency list. Let's pass in our adjacency list here. Let's give this a run. Make sure this passes everything. We need to return something. Let's just return... Let's create... let's create like some sort of res that we can return here, right? Let's make a little private section here. Let's do like vector of integers res. Let's just like turn out res. Okay. We should be printing here. Okay, so we have our adjacency list here, what we're working with. So let's see here. So in test case 1, we are given... Okay, so 1, 2, right? We got 1, 2. 2, 3, right? We got 2, 3, and then we got 1, 2 as well, right? Because it's an undirected graph. Then we got 3 goes to 2, 4, 2, 4. 3 goes to 4, and also goes to 2. So that looks good. 4 is 3, 5. That looks good here. And then our 5 should only have 4, right? Because it doesn't have anything outgoing. I originally thought about this as a directed graph, but yeah, and bidirectional cables. Okay. Okay. Okay, so how do we want to think about this now, right? So we have our adjacency list here. We know all our connections, right? We now obviously want to work with our queries here, right? So we obviously want to loop through our queries here, and we want to check the different types of them, right? It could be a 1x or it could be a 2x, right? So we obviously need to check the first value, right? If, you know, I don't know. I'm not a big like optimization guy. My initial thought would be just to loop through these queries, check the types, right? If it's a maintenance check or if the station goes offline. And like the way I keep track of if the station goes offline is have probably some sort of, maybe some sort of an array that indexes to the specific key of the station, right? And checks a Boolean variable if it's offline or not. Right, but obviously I think that's like super high time complexity. To be able to do that, I think we can do it faster. But I'm not really... I'm not really 100% sure. Return an array of the integers representing the results of each query type, 1x, in the order that they appear. So I believe we only... Right, so we just store the IDs of which power station goes offline. So I think really like when we see a 2, it doesn't really do anything, honestly. It just pushes it offline. I don't know. I'm sure it has a 57% acceptance rate. I don't know if that will work the way that I'm thinking about it. But hey, like, fuck it. Should we just, like, bowl out and do it anyway? I'm trying to think of maybe a fast way we could do it. But I'm not really too sure. Code forces or Leetcode, which seem more difficult? Bro, for sure code forces, but I'm not a pro DSA dude, bro. I just do it for fun, but I'm not good, so if anyone else has any ideas, I'd appreciate it. But I'm not really 100% sure how to think about it. Do I just go ahead with the way my just intuition of doing it? Or is there a better way? So really just to reiterate, the way that I would probably do this is I loop through the queries, check out queries, right? Check out types, apply the queries, right? What I mean by apply the queries is that, for example, this query here, you know, that this station is online here, like you can see. So the mains check is resolved by station 3. Station 3 is online, right? So it checks station 3. So we would apply ID 3, right? Then query 2, station 1 goes offline. The remaining online stations are 2, 3, 4, 5, right? And the way we keep track of this is we'd have some sort of an array that indexes these, right? With some sort of Boolean variables, right? So then every single time we get a query like this and that specific station is down, then we check the next station, right? And we keep looping and checking the next station. If all of them are down, then we instantly return -1, right? And we would just loop through this, right? But I'm not sure if that's the best way to go about it. I'm sure there is a faster way. I think you should start group each group of connections, and for each one you will have a heap. Is that the way to think about it? Group each connections. Union find. Ordered set heap priority queue. How can we group these? So I assume you're kind of hinting at me union find. I just don't really know how we would union find these. Union find these. Yeah, bro, I don't know. I only really know how to do it the brute force way. Let's ask for a hint. Blanco code, and also set all of the online nodes, so if it's online you will return it. If not, you will return the minimum one in that group heap. Okay. Let's see. So the brute force method likely hit performance issues, right? So build the adjacency list for each query, mark the station, time complexity estimate. Better optimized approach. Pre-compute the connected components using a DSU union find. Well, I wanted to practice Union Fine, so patients are currently online. You can see I'm a what is it? A data structures noob. I have to look up disjoint set, union find, think about how I can apply this data structure again. I mean, we were applying it the other day. I just don't. Actually, let's look at our old thing is. When were we doing? We were doing accounts merge here 7 days ago. Let's take a look at this. Okay. How did we do this? Right. So we had the find and we had the union. Right. We were just splitting up everything here. Right. Right. We keep a parent for this. So I assume we'd probably split this up using, well, if it's offline or it's online, right? I mean, that seems like the only logical way to split this up. I feel like that's just how you get better at these problems. You just gotta let's think about this, right? So I guess maybe we want to apply the union find here. Let's think about it. Okay. Guess this is a good learning point for me to. Hello, greetings from Colombia. Yo, what's up, dude? Appreciate you joining by. So DSU/union find. I think the adjacency list way is more simple now. Honestly, it could be. Try to think. Yeah, I guess what I'm doing here with the adjacency list not be required. You wouldn't need it, but let's see, what was some of the other ones? The min heap priority queue. So is this how you did it, Blanco? You did it with a JC list min heap? I'm gonna put some music, dude. Needs to be some music here, bro. It's too quiet. The only trick you want to know is how to group each connected nodes. Okay. Oh shit, my headset's not on. Yeah, I'm trying to think. I just don't really know how I'd apply a min heap in this situation. I'm not really super familiar with min heap data structures. I mean, I've done a few problems, but these are basic problems. But when you get to the harder ones like this, it's definitely tough. There's a video made by Leetcoding using this approach. There is. Okay. I'm gonna quickly read a hint from Claude, and then if I still can't do it, then I'll watch the video. Build the adjacency list. Hey man, just found your live stream. You got any tips, computer science undergrads like myself? I'm trying to avoid ChatGPT because I actually want to understand how to problem solve my code. Yeah, man. I don't know, dude. I use a lot of AI too, so I wouldn't like say necessarily it's a bad thing. You know, for these Leetcode problems when I'm learning, I try and use, you know, Claude as a resource in a way. You know, obviously not giving me the answer, but you know, guiding me into ways to think about it and the intuition behind the problem. Macaroni, yeah man, what's up, dude? You know, that's what I like about AI. It's kind of like a little bit of like your own tutor in a way. But you know, I wouldn't be using AI and just, you know, putting in the problem and then just, you know, copy and pasting the solution. I don't think that really helps, right? You kind of want to use it as a resource and a way to like guide you, like, you know, through learning data structures and algorithms for, you know, technical interviews and stuff like that. So that's my 2 cents on it. What engine are you using? Bro, I'm doing Leetcode. I don't know what you mean what engine I'm using. I'm doing I'm just doing some Leetcode. I'm solving the problem of the day right now. But yeah, that's my 2 cents, bro. So Blanco, you gave me kind of an idea, connected components. You want to know which components are connected. I'm just trying to think here. Connections.size. I don't really know how I'd split this into connection. I'm just not really getting the intuition behind it. So maybe I should watch Nico's video. Honestly, I think it would probably help me a little bit more.
Hobbs works hard.
Hobbs and Wild in pursuit of suspects.
Wild plays it cool.
Could you show me that clip again?
He posted 5 minutes ago. Oh my god, dude, he posted this video, bro.
This assignment, and I
Damn, bro, he's doing the Leetcode
How are we
solutions
supposed
again.
to find a
Kinda,
Hey
it's kinda
everyone,
W.
welcome back and let's write some more neat code today. So today let's solve the problem, power grid maintenance. And of course somebody on the Leetcode team must have thought they were writing like a 5-paragraph essay or something. But I'll try to give you the short version of this, just focusing on the examples. So the idea is that we're given a parameter C, and that's going to determine...
Yeah, 100% agree. I use it as a teacher too. It's actually helped me understand it more when it gave me some basic tutorials to follow on YouTube, haha, and gave me some mini projects of code. Yeah, man. I mean, that's the way to do it, bro. Like, again, like learning learning the code and learning some sort of framework or learning, you know, some sort of language really extremely well, bro, it just takes consistency and it takes a long time. You know, like, bro, I'm not the fucking smartest guy in the world, bro. I'm the most average guy there possibly is, but it's like, you know, just being consistent and, you know, just working at it every day is, you know, more than, you know, what most people do, right? So just, you know, just be confident in yourself and be confident in your ability and, you know, just trust the process and just, you know, learn everything and put in the work, and, you know, hard work pays off, so.
And the nodes in our graph. They don't explicitly tell us this, but they talk about edges and connections and stuff like that, so it becomes pretty obvious. Now, the graph isn't always going to look like a linked list like this, so keep that in mind, and keep in mind that
this is what confused me, bro. I thought it was going to be like a linked list sort of thing like this. Like, you're always going to
edges are going to be bidirectional. We're given the edges in a second parameter. Now, also remember that this parameter is going to be 1 indexed, so the nodes are going to be, so if C is 5, nodes are going to be 1 through 5. Every node is going to have a unique identifier. And so initially, we can say that all of these nodes are online. What does that mean in the context of this problem? Well, you can read it if you care, but I don't really care. So let's say initially all of these are online. Let's just run through the example. Well, we want to answer a bunch of queries, and there's 2 types of queries that they give us. And we can determine which one based on the first value of that query. So each query is going to be a pair of values. The first value is going to be 1 if it's this type of query. It's going to be 2 if it's this type of query. The second one is a lot easier, so let's start with that. So if we see a query like this one over here, 2, 1, that means it's the second type of query. We go to node 1 and we take it offline. That doesn't mean the node doesn't exist anymore. It just means it's not online anymore. When we do that type of query, we don't do anything. We don't need to return any sort of result. But when we have the first type of query over here, 1, 3, then what we want to do is go to the node 3, and we want to ask the question, is 3 online? Because if it is, then the answer to this query is going to be 3. And in this case, it is online. So that's why you see in the output, the first value is 3. So we answered that query with a 3 value. What's going to be next? Well, that was the other query that we already went over. And remember what I said, that one we don't need to answer it. We don't need any output value for the 2 type queries. Okay, next we have this one. So remember, this one went offline. So now we're here, 1, 1. So it's the first type of query, and we go to node 1, which does exist, but it's not online. So now, if it's not online, the answer cannot be 1 of this query. So now, to resolve this query, what we do is ask, since it's offline, we want the operational station with the smallest ID that's in the same power grid as, in this case, 1. If no operational station exists, then we return -1. So what do they mean by power grid? That's kind of what I glossed over at the beginning. But in the context of this problem, it's basically going to be a connected component in terms of graphs. If you don't know what a connected component is, I would highly recommend learning a bit more about graphs. Plenty of resources for you to do so. I would check out Leetcoding if you like my teaching style. I said connected graphs, but what I meant is connected component. And that just means that these stations are directly or indirectly connected via edges. So in this problem, it's really kind of simple because we just have like a linked list. So this is just a single connected component. But imagine that maybe this edge didn't exist. Then we would have started with 2 connected components like this.
See,
and
I think that's where I went
connected
wrong,
components could
bro.
be more interesting. They don't have to be a straight line. We could have something like this and maybe something like that. So
This is my favorite
That's where I
dentist
went
hack
wong
to
in my
clean my
thinking.
retainer.
I thought they
If
were
you wear a
all
retainer
initially
every night like
connected,
I do, you know how hard it is to keep it.
you know,
keep
we're
that
gonna
in mind. But in
potentially
this
have different
example, it's pretty
paths.
simple, so I'll try to finish this one.
I understand.
So among all of these, which one has the smallest value, the smallest ID that is still online? Well, in this case, it's 2. And
Right, so I assume we're probably gonna have to perform some sort of BFS here to I want to know which nodes belong to which grid connected component. This happens once before queries. Yeah, it also got me. Yeah, bro, I mean, they don't really fucking explain that in the solution. Like, I mean, in the problem description. at all, bro. Like, okay, so let's think about this. Damn, bro, I feel like this is gonna be a long ass fucking solution, bro. So before we continue, let's think about what we got, right? We have a proper adjacency list, right? We need to perform some sort of BFS on each node, right? So go through each node and perform some sort of BFS, right? I appreciate that, dude. It's a completely new way to look at how computers and softwares function, so it just feels a bit overwhelming at first, but I'll keep working on it. Yeah, man. That's fine, bro. Just keep working hard, bro. Hard work always pays off, so. I'm just trying to think about this. How can we kind of perform this, right? So step one, right? We created our adjacency list, right? Step two, right? We have to use, we can use BFS, or I guess DFS to, I guess like create in a way the connected components in the graph, right? And then three, we'd have to like apply the queries. We'd have to apply the queries using a min heap, right? The thing is that I don't really understand fully how I'd wrap this BFS inside of the min heap. That's what I'm a little bit confused about. Because I can easily perform a BFS, but I just don't really know how to like to weave in the min heap here, and the way to think about it. That's what I'm trying to think about here. Maybe we should just keep watching the video for a little bit, and maybe.
And one way we could figure that out is maybe just starting from here, running some kind of graph traversal on this connected component. Exactly, it could have been a DFS, or it could have been a BFS. Maybe it's not the most efficient because we would have to iterate over the entire thing, but it is a possible way to do it. So the answer to that query is going to be 2. So that's what we're going to put in the output. And then finally, we have another query over here. We're going to take now 2 offline. So get rid of 2. And then we're going to have this query. It's the first type of query, and we're going to node 2. So we're here. What's the smallest ID of a station that's still online? In this case, it's going to be 3. So we will put 3 in the output, and that's what the output is. You can see here it matches. Okay, so now we know what we're trying to do, but how exactly do we do it in terms of making this efficient? Well, first of all, recognize that we're going to have to convert this list of edges into a way for us to actually traverse the graph. And we can do that by converting it into something called an adjacency list. And if you're not familiar with that, I would definitely probably not attempt this problem just yet, to be honest. So that's what we're going to do. It's a pretty trivial step. We just use a hash map. Once we have that, we want to be able to separate the nodes, because this example is really simple, but imagine we have something like this. I have a 6 node, I have a 7 over here, I have an 8 over here. So now we have 2 connected components, that one and that one. We need to be able to differentiate these nodes from these nodes. I guess you wouldn't necessarily have to, because it's true in the naive way where every time we're just given some node, we immediately go to that node and maybe we then run some kind of traversal on it. It's pretty much expected that we're never going to land on any node outside of that connected component if we're DFSing or BFSing. But ideally, we wouldn't have to run a traversal every single time like that. Is there a faster way? because for every connected component, can't we just track the minimum online node? Because if we track that, then we can always return the query very quickly. We can pretty much answer each query in constant time. Now, we could, but it's not going to be quite that simple, because imagine something like this. Imagine for this connected component, we have 6, 7, and 8. What if we tracked, okay, the minimum right now is 6, and that's fine. And maybe we remove or take 7 offline. So 7 is offline now. Okay, well 6 is still the minimum, that's fine. But now we take 6 offline. Okay, now how do we find the new minimum? It's not trivial to do that. We might have to run a brand new traversal on the graph, because we can't just say, okay, well, it's going to be one value bigger now, because actually 7 doesn't exist either. 7 is offline as well. So it has to be 8. There's no easy way for us to figure that out. And that's why we're not only going to track the minimum value, we're actually going to put all of these values into a min heap, because that way things will naturally work out. And this is roughly how it's going to work. So imagine all these 6, 7, and 8 are in the min heap. So I'll just kind of draw it like this. So let's run through that exact same scenario I talked about just a second ago. What's the minimum right now? It's 6. And we can get that in O of 1 time, because this is a min heap. We're not going to be removing it. We're just going to be reading it. So that works. Okay, now what happens if we removed 7? We took 7 offline. Well, first of all, we have to mark that somehow. And your first way to do it would be probably to think of removing it from the min heap. But it's not so trivial to do that, because a min heap, it's going to require us to remove 6 before we can remove 7. And we don't necessarily want to remove 6. So a better way to do it is, I guess I would call this like a lazy delete, because we're going to mark 7 as deleted. But we're not going to mark it as deleted from the min heap. We're going to use another data structure. My preference is to use a hash set. So what I'm actually going to do initially is just add all of the stations initially to the hash set, which I'm going to call the online hash set. So now we can immediately know for any node, is it online or not? And so when 7 goes offline, all we do is remove it from the hash set. That's going to be a really quick operation. But now, when it comes time to make another delete, and before I run through the case where we delete 6, right now, if we wanted to get the minimum from our min heap, it's still going to be 6, and that's fine because 6 is online. But now, suppose we remove 6 from the min heap, and once again, we're actually just going to do a lazy delete. Not because we necessarily have to in this case, because that actually is the minimum, but just because it's going to make the code a bit nicer. So still a lazy delete. We're only going to remove 6 from the hash set. But now maybe we go to 8 and now we query it. We ask, like, what's the smallest station that's online in this connected component? Well, we're going to go to this min heap. We're going to have a min heap for every single connected component. And now we're going to check. Well, is 6 the smallest? Because 6 is the smallest in the min heap, but 6 is actually not online. So we're just going to pop 6 and not do anything with it. Next, we're going to do the same thing with 7. Is 7 online? Nope. Get rid of it. And finally, we'll go to 8. 8 is online, so that's what we would return. This seems kind of complicated, so let me make it very clear why we're doing this. Because what we did just now is, in the worst case, we're going to possibly have to pop from this min heap. And obviously these values are going to be pushed as well. But that time complexity is going to be like the size of the connected component, which in the worst case, I think would be n if we just had one really big connected component. I guess I'll use the variable c because they give that to us. So in the worst case, it'll be c, and pushing and popping from a heap is going to be log c. So that's not super bad. Compare that to before, where instead of having a heap, every time we run the query, we have to traverse that entire component, check each node. Okay, is this one online or is it not online? We could do that with the hash set, sure. But if we did it that way, for each query, we'd have to traverse the entire component, which would be C. How many queries are we going to have? It's going to be, in the worst case, I think Q. I think in this problem, roughly C and Q have like the same upper bound based on the constraints of this problem.
Okay, let me think about this. Okay, so somehow we're gonna have to use BFS to label these IDs. Let's think here. Where's my code, dude? Oh, here. Okay. Let's think about this. How do we want to perform this? Do we want to abstract out these into methods? Really? There's a grouping trick. That's all lol. Yeah, so is the grouping trick like using a hash map? Like a I guess, what do we want to call this in this case? Like node. Let's unordered map intent. Call it node to comp. Right? What this is gonna do here is it's gonna map each node to a strongly connected component, right? Right. So we probably need some composition ID. Let's do comp ID is equal to 1, right? Comp ID, oh, we can start from 0. Probably need to define our priority queue. I don't even know how to define a priority queue in C++. Priority queue, let's do define. Yeah, priority queue, C++, like min heap sort of thing. Int is the data type. Stored vector is the underlying container used to store the heap elements. Okay, greater is a comparative function object that ensures the small sum is always at the top, effectively creating a min heap. Okay, so let's just take this code here. We can get rid of the stood. Let's call this a min heap. All right. I assume we're probably going to need some sort of visited set, right? Set int visited, right? I'm not really sure about this yet. What do we want to do here, right? So we have probably want to loop, right? Starting from the node that we want to start at, right? So we int I is equal to 1. I is less than C plus 1, right? We want to include the 5th node. Leetcoding C++ is a pain in the ass, but good for long term. Yeah, I mean, yeah, I agree. To be honest, I kind of disagree with you in a way too. I feel like it's all about just the concept, right? I mean, like at the end of the day, like, you know, programming language is just syntax. You know, maybe Python's going to be a little bit shorter or a little bit more intuitive or whatever, but like, you know, I feel like it's the same thing. And it's like you still need the same intuition anyway. But guess we could do actually less than or equal to C, right? Equal to C. I++. I love C++, and I'm so happy that I switched for the long term, and you know, it's helped my fundamentals so much, bro. Like, it's insane. Like, you know, so I'm not even that good, but it's like, you know, I'm learning about 3D graphics programming, you know, and trying to get better at that, and trying to learn something new that interests me. So I don't know. Guess we'll see. But okay. So this year, right, we're looping over our nodes, right? And what do we want to do, right? We obviously want to check right, like if visited.count .count I, right, if this is false, so I can't remember how to do this exactly, but let me check what it said. C++ documentation. Has a .count method. One if an element with a value. Okay, so it returns either 0 or 1. So the visited.count I guess if this is 0 in a way, then so does not exist, right? I just like to kind of, when I'm not sure what I'm doing, I like to map out what I'm doing, right? What do we want to do here, right? Well, we have a composition ID, right? We have our unordered map here. We probably just want to increment, right? So we want to increment our comp ID. I'm also switching from Java to C++, so I'm tired of web horseshit. Yeah, bro. We increase our comp ID, right? Right, what do we want to do here? Well, we literally want to append it to our queue. Do we need a basic queue here? See, I just don't really know kind of what I'm doing.
So in terms of the comparison, the belongs to, as long as this one has,
he's doing a DFS, he's on a JC list here.
Isn't already to get all of the neighbors of.
Now he's kind of doing the same thing. I think he mentioned it. Don't want to look at the code. Comp ID. This here is our min heap, right? I think we're gonna need some sort of normal queue, right? So let's define that out here. We can have some sort of normal queue, like queue int queue, right? And we can go queue dot, I think it's push, right? And we can push the element that we want to look at, right? So the node we want to check. What is the node that we want to check? Hi, right? So can't remember what the operator is, dude. Yeah, it's push. That's what we got. Okay, so we push I. We increase our comp ID. We push I. Is that it? I guess would we want to add to our visited, right? Visited dot add I, right? We have a set, we have a priority queue, comp ID. While queue.empty. Let's push through, right? So while there's nothing in our queue, so while there is something in our queue, while something in queue, what do we then want to do, right? We're inside of our queue here, so this would be comp ID. We want to pop, so we go q dot, I think it's top. Q dot front. Q dot front, right? So we can go like auto LE. It's Q dot front. And then we can go Q dot pop to pop, right? We then want to add it to our node to composition, right? So we would go, okay, well, would this be a vector of integers here instead of integers? Yeah, but isn't that PQ for all the nodes? Yeah, it is, but I thought we'd have to split it up to components here. I'm using a separate data structure to split the components. I thought that's the way he was talking about it in the video. So node. Am I wrong for doing this here, Blanco? Or node to comp LE is equal to our composition ID, right? Or should it be comp ID to LE? I don't know. Shit, bro, this is a fucking hard problem, dude. I need to get better at priority queues. I think I'm gonna stick with what I got. So LE, and then the value of it will be the composition ID. Yeah, I think you should split that queue into different ones for each group ID. Component ID. Yeah, I think you should split that queue into different ones for each group ID. I don't know what you mean by that, to be honest, Blanco. If you could explain a little bit more. All I know is here is that the next part here is we're gonna have to loop through our neighbors, right? Loop through our neighbors. Alright, to do that here we go for int where are our neighbors stored? For each component, you should have a min heap. Okay. I'm confused now, bro. I'm getting confused.
Hey everybody, Peach here, and today we're going to take a look at the Speediant Gym Monster 2, which is an all
We can get with our hash.
So let's go back to the part where he actually builds his DFS here. Let's figure out what he's doing here.
Group IDs. So just reuse that. That's the easiest thing, at least in my opinion. So we'll have two parameters here, station, group ID, and we'll check, has this station already been visited? If it has, we'll return. Otherwise, we will mark it as visited. Then we will say station group. We can map this station to the group ID that we passed in. And lastly, we can update the min heap that this one belongs to. So we'll go to min heaps, which is a hash map. We will use the group ID. It's possible that this is just an empty list. That's what default dictionary will do. And if it's an empty list, that's perfectly fine, because either way, we're going to run heap push on this, and we're going to push the current station. And then after we're done with that, all we have to do is use our adjacency list to get all of the neighbors of the.
Man, it's so impressive to think about it like this, bro. Like, it's like, dude, fuck. Neighbor in adjacency list. For a neighbor in adjacency list, what do we really want to do, right? We want to, if visited dot count neighbor, so if it's not there, we want to do visited dot add neighbor, and then we want to q dot append our neighbor, right? I think that's correct. Where's a q dot push actually? Okay, so we looped around neighbors here. I think we are missing something. I'm not really using our priority queue, but the thing is, I don't really know how to fucking use it. I think we have to add this to our min heap here. So this is the type that's all. This is the data structure. We want the greatest element at the top. So you will have to map between each component ID to its min heap using hash map. Okay. Min heap. I'll push Ellie. Min heap comp ID dot push Ellie. So our node to composition, this marks our groups, right? So node to comp Ellie is equal to comp ID, and then our min heap here, comp ID. So I think I kind of know where this is going. I think honestly this is good for the PFS approach here. We have a 4 here. So when we apply our queries, like what Leetcode said, I think we need another visited set here. So we go visited, unordered set, int visited. We don't call this visited, we call this online, right? For what is our queries? Actually, let's think about this, right? Let's actually print what we got so far, right? So let's visualize it, right? We'll print we can print everything here. Just to visualize it. Let's just get Claude to generate this. Okay, so we don't need this. Don't need this. Can you write me some print functions for these types? I just don't want to write my own, dude. I feel like it's not worth it. Print map. What is this giving us? A this creates a copy. Okay, yeah. So it's using the copy constructor here. Let's grab these elements. Let's take this code here. Let's go to our print functions down here. Move this across. This across. Yep, that looks good. Let's get rid of this bullshit. Okay, so now we have a print map. We have a print min heap. Let's kind of get a visual of what we're kind of looking at. So this is our BFS. Right, BFS. We want to. Let's take a look. Print map. And we can call our node to comp, right? And then let's just take a look at that first. Not getting too much. So I'm gonna need to fix up all this. I believe this is insert, I think. Instead of add. I think add is in Python, but I think this is insert. Does not provide a subscript operator. I don't know what this means, to be honest. What does this mean? Need a different data structure. Oh, right. So we're doing this wrong. We need a vector. Okay. Unordered map, int priority queue, int vector, int. And this creates it as a min heap. I think that should work. Hell yeah, bro. Team killer. What's up, bro? Okay, so that worked. That goes together. For int neighbor in adjacency list. Stood pair. For int neighbor in adjacency list. Oh, whoops. We need to neighbor in adjacency list Ellie, I believe is the fix here. There we go. Okay. Map here is size 5. We print 1, 2, 3, 4, 5. Right, that's correct. But what about for... I guess we're not going to see that. But I guess looking at this test case here, this works, right? I mean, it's printing exactly what the comp ID is, right? So let's get rid of this code. Let's do a print. What do we call it? Print min heap, right? And let's pass in our min heap. So where is that min heap? What did we call it? Min heap, right? Let's print it. Oh shit, we did change the type of it. Whoops. That's why it's not working. So this ain't gonna work anymore. Because we did change the type of this. Can you make a print function for this type, please? That's the other thing I don't like about C++. It'd be nice to have like some, I don't know, built-in print function instead of writing this garbage. Like, I'm not gonna write this myself, so let's grab that and let's replace that. Let's grab this here. This. Or what is going on here? This looks so weird. Let's just leave this for now. I mean, this will work, right? We don't need to leave this in the code, but let's print map of heaps. Let's take a look here. Map of heaps, size 1, comp ID 1, 1, 2, 3, 4, 5. Okay. So this is comp ID 1. Has these here, right? So the keys are consistent upload vectoring keys for console key value in M. What is M in this case? This here, key stop pushback key. Okay, let's get rid of this. I don't want to see that garbage anymore. Okay, so I think we're on the right track, right? And I think what we have to do here... This is the part that I'm a little bit confused about. Well, I guess I've been confused about every single part, but... let's get rid of this. So, we need to go 4... Q in queries, right? We need some sort of online visited set, right? So unordered set. Test case 1, they are all connected. That's why all appear in the same heap. Yeah. Thank you. I did see that. You can call this online, just like exactly what Leetcode has, right? For Q in queries, every single query we see, we want to check the type, right? So, yes, if Q0 is equal to 1, right? We can do this, right? Else if, that is literally Python, else if Q1 is equal to 2, we do this. Everything initially needs to be in there, So everything's initially online. So let's go for int I is equal to 1. I is less than or equal to, what is this, C in this case, right? C I plus plus, right? And we would go C I or visited dot insert I, right? Everything is online at first, right? Okay. If queries, if Q0 is equal to 1 or Q0 is equal to 2, in this case here, we just want to remove our visited, right? So this is now offline, right? Visited.remove Q1, right? That's all we have to do for that case, right? Otherwise, in this case here, I guess this can literally just be an else, right? Let's just leave it as else here. Fuck it. It's alright. I think it'll still work. Otherwise, for the if case here, this is the case that is the hard part here, right? So maintenance check is requested for station X. If station X is online, it resolves the check by itself. If station X is offline, the check is resolved by the operational station with the smallest ID in the same power grid as X. If no operational station exists in the grid, we return -1. So, we have our min heap to do this. So I guess what we'd have to do here is we'd have to query the element we have in here, right? So whatever element that we're looking at. Test case 1, just use the visited set, no? Sorry, visited. Whoops, this is online. Let's get rid of this garbage. Whoops, sorry. Use the visited set. Well, no, I mean, I believe the visited set in this case has everything else, right? I mean, this applies to the hash map. I don't know. Maybe you're right. I have no idea, bro. My intuition is just to create a new set, an online one. You know, I know that everything's in there. I don't know. This is my intuition. For queue and queries, we check this. So we've done this part. Remove it, right? The way to do this part here is we need to find the int component. We can call it comp is equal to component, right? Int component is equal to how can we find that? See, I don't really know how to do this part here. Holy fuck, dude. How the fuck do I do this? Node to comp with the LE. So we're looking at... So what are we... Hang on. Where are we storing this value? Comp... Node to comp LE is equal to comp ID, right? So we would use this hash map and we would grab our ID, right? So we'd have to go node to comp and pass in the I that we're looking at, right? I think that's correct. That will allow us to grab the component ID, right? And we can use that component ID to grab it at the priority queue, right? But honestly, I don't really know the syntax to do that. I'm not gonna lie. Shit. But I know we're going to need the comp ID to be able to... Not super familiar with priority queues, but... I grab things from this. What a shitty, I don't know the syntax or anything. Auto PQ min heap comp gets the reference to the priority queue. So we use the comp ID like what we did, and we get the reference. Get the smallest element top of the heap without removing it. Auto reference PQ. Okay, let's grab this. So we can reference this here. Alright, so we grab the priority queue. Let's see here. The common operation elements. So get the smallest element, top of the min heap. Right, so that's probably what we want to do. We want to grab the smallest element, right? Remove the smallest element, pop from the min heap. We obviously want to compare what's in our visited array, right? Because this is what's online, right? So if that element isn't online, right? I would assume in this case we'd probably maybe want to just go to the next value, right? Right? So maybe we'd have some sort of if check and check, okay, well, is this component online? Oh, sorry, is this value online, right? If it is online, then, you know, we return that. That's the smallest value. Otherwise, we, you know, just delete it, right? I think that's the way to go about it. So if online.count, I believe PQ in this case is an integer. I mean, we are working with integers for everything, I think. I just want to check, actually. I don't know. Does this return an integer? Does this return an integer? If it's empty, then return -1. That's it, bro. Or to the entire min heap priority queue for that component ID. To get an integer, you need to call .top. Okay, I get that, but we have auto reference, but what is the type here? This is why I don't like auto sometimes. I just don't know what the fuck is going on. The type is, okay. The auto keyword is deducing this type automatically. Okay, so this is the type. Okay, so we're the elements. We need to actually use... Okay. I'm getting there, Blanco. That's it, bro. If it's empty, return -1. So this actually grabs the min heap, right? And we want to grab the topmost element. So would we go if online.count pq.top? Right, so if this returns true, then we would just want to append here, res.append, res being the array they're actually in our private section that we're going to return here. So res.append, like pq.top, right? Otherwise, if it's false, then what do we want to do? This is the hard part, right? You said if empty, then return -1. If online.count pq.top, I guess we'd have to check if it's pq dot, is pq even like, I don't know, dude, like, Should priority queue. I'm not familiar with the... Does it have an empty, bro? Oh, it does. Okay, so that's good. So we probably have to check that if it is empty. So pq dot... So pq dot empty and online dot count pq dot top. So if it's not empty, right? So not empty and top value is not empty and top value is online, right? We would append, right? Otherwise, right, we would just... We wouldn't return -1 though, right, Blanco? We would probably return... we have to return the next value, right? So technically, do we just like pop? I don't know. Else while pq dot I guess while there's something in PQ, right? Yeah, we will pop until there is no online left there. So while there's something inside of PQ, right? Not empty, right? So while .pq dot is empty, and online dot count pq dot top is 0, right? So this... Okay, else, if this exists, then we keep looping, right? So while this is not empty and it's not in visited, right? I think we got a little bit too much there, brackets, but never mind, we need one more. Then what do we want to do here? Well, we just want to keep popping, right? So we go pq.pop, right? Then we would have to I guess we'd have to do a case here. Well, if pq.empty, then in this case here we would literally just return -1, right? Maybe this should be checked outside. So if this is empty, we would not return -1. We would res.append -1. Otherwise, if pq is empty and online.count pq.top, we pq.pop. Append -1, sorry. Yeah. So it's not empty. So while pq.empty and it's not unvisited, then we pop. If pq.empty, we res.append -1. But what about the case where it is there, right? We need to also apply to this case where... Okay, well, what about if... Oh, shit, dude. I think I'm getting fucking too many ifs and shit, you know? Like... pq.empty... Okay, I guess we'd have to check here. Well, if pq.empty and it exists, right? So an element exists, then we want to res.append the value here. So we would go we would append in this case pq.top. Holy shit, dude. That was literally AIDS. Like, I don't even know if that's right. There's definitely fucking something wrong in that, but I think I got most of the cases. Then we would return res. Let's see. See what this gives us, bro. Okay. We need a type here. So I guess this is shit. I need, I guess, const auto, right? It's auto reference Q. Use of undeclared identifier I. This should be Q. No viable overloaded operator for type unordered map QQ. Whoa. This might have to be a... Whoops, hang on. What is our queries here? This is a 1. This is a vector. So we need to pass in the second part here. Right? So we need to pass in Q1, I believe. Okay. Res.append pq.top. There is no append. What is it? I think it's push back, actually. Yeah, that sounds right. Push back. This is push back. Let's replace everything with push back. Bro, this is ridiculous, bro. This is a really hard problem, dude. Like, I think, personally. Visitor.remove Q1. What is it? Remove arrays. Arrays elements. Arrays. Oh. Implementing 1 everywhere. So what are we doing wrong here? We are appending 1 everywhere. A pq.empty and online.count pq.top res.pushback pq.top. What is pq.top returning though? Maybe pq.top is returning is it returning the value that we want? I wish I could just print PQ here, dude. I think PQ is the vector, right? That it's storing all the elements in, technically. I'm not really too sure. Because I think in this case, it's not really going to this else case here. It's really just appending these. So I think the issue is in here. But I'm not really, again, I'm not familiar with priority queues that much. So let's grab this code. Wait, where is all the code? Let's actually grab the whole thing, because why not? Yeah, let's grab all of this. Let's debug. Because I'm not sure, I'm not familiar with priority queues that well. Oh my gosh, dude. No way, bro. This was my issue, bro. Nope. Oh my gosh, I'm erasing from visited too, bro. No way, bro. Okay. This should be online. Okay, we're getting somewhere. What are we getting here now? 1, 2, 3. Cleanup logic can be simplified. I make these stupid mistakes everywhere, bro. Like, this is why if I was asked this in an interview, bro, I would probably shit my pants. Like, bro, I probably spent 2 hours on this problem already, bro. Like, how long have we been doing this? Bro, I've been streaming for nearly 2 hours on this problem, bro. Okay. So we're still missing something. I obviously think my logic can be simplified. But there's still something wrong here. And I'm not really too sure what it is. So, missing check if the query node itself is online in the power grid maintenance problem. So we're missing the check if the query node itself is online. So how am I missing this? See, I don't know why I need this part here, because I would have thought with a min heat, if it's online, it's going to be the least... Right, like... I think maybe... Yeah, it's very hard, bro. They literally give 5 hands fall. Yeah, it is tough. So, looks like the AI is telling me that I need to do a check here. But I don't know if this check is correct, because I feel like with my knowledge of a min heap is that the most minimum value is always going to be the first value anyway. So I don't understand why I need to make this check here. Station here being Q1. Res push station, we continue. Right? Because I feel like the most, it's going to grab the most minimum value anyway, right? This is weird to me. I think this check here is wrong. Pushback. I think you should just add it if it's already online. Why get it from the min heap? Yeah, that's what it's saying here. I mean, I don't know. My intuition was to just get it from the min heap, but bro, like, I have no idea. Like, wow. So that was the fix. Grab the initial value from in heat. Let's see if this passes there. Wow. We were the slowest. But you know, fuck it. That shit don't matter, bro. But I'm confused why we need this part here. I know my logic is probably super redundant too. This here is probably garbage. It works, but like... We did miss this part, and I don't get why we need this. It's great you're asking why. Let's break it down. If the power grid means tomorrow, when you get a query, like find the smallest line. One of the prompts. If the query station X itself is online, return X immediately. You don't even need to search its component. Well, I think I can sleep now, lol. Thanks, Blanco, dude. Thanks for joining the whole time, bro. I really appreciate it, dude. Thank you for helping me, dude, and being there with me. You spent 2 hours solving this problem with me from the very beginning, so I do appreciate you being here, dude. Thank you for that. That was a ridiculous problem, though. Like, I think what I got confused from here is that, so I believe if we do this here, I don't think we would need this. We just grab the element if it's online. Otherwise, I don't think we would need this part here. I think we would literally just need all of this bullshit down here that searches for the next element. I don't even think we'd need this part. And I'm going to confirm that. Yeah, I understand, Blanco. I understand why. Right, so I am right. I am right. This is not needed. Right, only these checks are needed, right? Because we're instantly returning now, right? This check here was to grab the most minimum value, but I think this is somehow wrong, I guess, in a case. But hey, I mean, it's all part of the learning process, so it's like, yeah, this was an extremely tough problem. I mean, dude, like, I'm no DSA legend or anything, but like, dude, that was hard. I'm not gonna lie. That was really tough. Let's check what that was rated. I'm curious. Elo problem rating. Leetcode. Let's see here. Let's grab what we have. Power grid here. Here is Leetcode 457. Oh, whoops, 457. 1700. Wow, man. I mean, I don't know, dude. That's tough, bro. Like, wow, this is a fucking tough contest, bro. Like, holy shit. Like, minimum moves to reach target in a grid. .1 acceptance rate, dude. Jeez. Leetcode contest 457. It was only a few weeks ago. 457. Let's see how people did on this problem. I'm curious. 5,000. Dude. Bro. Solve that problem in 12 fucking minutes, bro. What? That is fucking crazy, bro. How do you solve that problem in 12 fucking minutes, dude? Like, 5. Bro, there's people out there that solve that problem in 5 minutes, dude. That is fucking incredible, dude. Like, wow. That is really, really impressive, dude. 6 minutes, dude. Bruh. Like, dude, what? Bro, it shows my level. It took me 2 fucking hours to solve that shit, and I needed help to solve it. I guess people just know the intuition off the spot, and they can just blast it out the way. Bro, that's really impressive. Like, yeah, dude. That's like really impressive, but even 20 minutes, bro, I think is pretty good. Like, let's go to like page like 170 or something. Like, wow, dude. Even one incorrect attempts. Wow, like even, you know, people are getting this problem here. You know, top 4,000 people. That's still impressive, dude. I mean, I don't know if I'd be able to do it in a contest without any help or anything. This guy's a 1600 rated. Then again, I mean, I don't know how many people are cheating in this shit, so it's like, this is probably inaccurate too. I just don't know how someone can reach that level. Yeah, I mean, dude, it's kind of crazy, but, you know, I don't know if I would have been able to solve that problem with no help whatsoever. I don't think the brute force approach, I think I could have brute forced it, but I don't think it would have been accepted, so therefore I don't think I would have solved it under the constraints. With the priority queue. Look, this guy, this is probably more, it'd probably take me an hour. Even these people are solving it. How many pages are there, bro? There's 1,000 pages. Let's take the top 50%. Let's go 500. Yeah, so the top 50% of people are solving this problem. Not even the top 4, only the top 40% are solving this problem. That's crazy. That makes me feel a little bit better, but yeah, so top 40% of people doing this contest. Wait, hang on. 40. Whoops. Whoops, dude. 100. So the top 40% of people aren't even solving this problem. Let's take a look at this guy's profile. It was 1524. Solved about 300 problems. 252. 468. I guess it just depends on the problem, but it's like, yeah, it's interesting. I do want to do one of these Leetcode contests one time. I feel like it'd be fun, but dude, it's just like, for me, like a Saturday night, bro, like I'm out hanging out with friends. I don't want to do a Leetcode contest, you know, like, wow, even the top 35% aren't even getting it, dude. That's fucking crazy. $350, 300. Yeah, top 30% now getting it. Crazy. Anyway, I was working a little bit. Oh, dude, no, dude. I was working a little bit more on the, not this application. I haven't cloned it. I don't want to do the repo. I've been working a little bit more on the fraternity application that I'm building. I kind of got the Stripe payments set up, but oh, looks like one of my buddies made a pull request to this. Take a look what happened. Wait a page, almost done. Holy shit, dude. What the hell did this guy do? Bruh. What is going on here, dude? Get menu. Index.js. Get order items. Delete order items. So delete order items based on ID. Date worker role. Payments post table. Oh. He actually did the payments. Payments post table, API payments. Crystal body. From payments. Insert order ID, payment method, amount, payment time. Order ID, payment method. Get API, get payments. Feature waiter page. Why is he editing all this fucking shit, dude? I have to check my phone, bro. Let me check my WhatsApp, dude. Yeah, I was going to work a little bit on my fraternity application, but I don't have the repo on my computer right now, so I don't think there's really any point. I think I'm just going to do some 3D, keep going with some 3D, some graphics programming, keep learning. But I have to kind of review this, and I don't know why there's just so many changes here. 20 files viewed, dude. Like, why is he changing so much shit, bro? Like, 14 commits into main from... Oh. So he wants to merge everything. Wants to merge 14 commits into main from feature waiter page. Ah, okay. Yeah, I gotta call my buddy, but appreciate you guys watching. That was a long ass problem. I wish you could have done a little bit of project work on stream, but it took a lot longer than I thought it would. But we're gonna keep going with the project work. I mean, I work on my stuff every day, but I don't know, sometimes I just don't feel like streaming sometimes, so it is what it is. But appreciate you guys watching. You know, if you guys want to, if you guys can follow my GitHub, I would appreciate it. Make me look better than what I am. But thank you guys for watching, and you know, appreciate all the love. So peace. See you guys later.